Today we have Dr. Lalita S. Kumar with us from School of Sciences. She is professor in chemistry. This program is for pharmaceutical chemistry. This is a 8th unit of this course. It deals with the fundamental portion of the chemistry. As you know, organic chemistry is a chemistry of compounds of carbon and hydrogen elements. There are more than 100 elements in the periodic table, but with the combination of carbon and hydrogen, mainly carbon and hydrogen, organic compounds are more than millions. So it is very difficult to remember this compound or to recognize this compound. To overcome these facilities, we have classified all the organic compound in different categories. For example, you know there are number of countries in the world, but each country has different type of people. For example, if we can divide the world in different countries. For example, in Asia, and there are Indian people, Chinese people, or Japanese people. They have some similarities among themselves. Similarly, in the organic compounds, we classified the compound which has similar characteristic. So we divided the organic compound into different categories known as they have different functional group. What is functional group? Functional group can be defined as an atom or group of atoms. Remember, atom or a group of atoms in a molecule which exhibits characteristic chemical properties. First class is alkane. The example is CH4, name is methane. Similarly, alkene, here the functional group indicated by carbon-carbon double bond. This is the functional group, and this is the one of the example, ethylene. There are a number of alkenes with the varying carbon chain. Carbon, in this particular case, we have only 2 carbon atoms, but you can have number of carbon atoms. In petroleum, which we use generally for our motorcycle or car or this, we have we use petroleum. But what is petroleum? It is nothing but the carbon chain. This is a combination of carbon and hydrogen only. Then alkyne. In alkyne we have carbon-carbon triple bond. Example is acetylene. Similarly, cycloalkane. This is the example of cyclohexane. Next one is aromatic compounds. Aromatic compounds are those compounds who has 6-member carbon chain, cyclic carbon with alternate double bond. It may vary. It may be of 5-member or others are, but mostly aromatic compound of aromatic compounds are of 6-member cyclic ring. Then alcohols, or the OH group is the functional group of all the alcohol. On all alcohols you will find OH group is attached to different carbon atoms. It is in this case, in this particular case, this is CH3OH, but the carbon chain can vary from 1 to 20 or 22 or. Similarly, phenols. For phenols, functional group is this OH attached to the aromatic ring. Example is this is the one. Similarly, ether. In ether, one oxygen is attached to alkyl group. Alkyl group is CH3 or C2H5 all of you know very well about the alkyl group. We will not go in detail about regarding this thing. Then aldehydes. The functional group of aldehyde is C double bond O and H. One carbon is attached to hydrogen atom and one carbon attached to with oxygen with double bond, and other is attached to the alkyl group. This is the example. Similarly, ketone. There is a little difference between ketone and aldehyde. In aldehyde, carbon oxygen double bond with hydrogen, but in case of ketone, carbon oxygen double bond is attached with two alkyl groups. Carboxylic acid. In carboxylic acid you will find carbon oxygen double bond and one side of carbon is attached to OH group. Example is acetic acid. Similarly, esters, here carbon oxygen double bond, then the same carbon has a bonding with oxygen is attached to alkyl group. Here oxygen is attached to OH group, and in this case oxygen is attached to alkyl group. Similarly, anhydride, and so on. Now come to the very important aspect of the organic chemistry, that is the nomenclature. Aromatic compounds have following types of basic skeleton: single aromatic ring like benzene or its derivative, then polynuclear hydrocarbons, that means more than one aromatic ring is attached to each other, and then heterocyclic compound. In heterocyclic compound, first two type we have only carbon ring, but in heterocyclic compound we have ring with heteroatom. Heteroatom means other than carbon atom. The first category was benzene and its derivative. Benzene is considered as the most popular aromatic compound, most common aromatic compound. So that's why in number of cases we consider it as a parent hydrocarbon. This is a derivative of benzene. If you delete this chlorine, it will be benzene, and it is a derivative of benzene. Halogen and nitrogen attached to benzene are prefixed to benzene. Here we call it chlorobenzene. This is a chloro group, chlorine is a chloro, and this is a benzene, so we call it chlorobenzene. Similarly, this is a nitro group and this is a benzene, we will call it nitrobenzene. And the second type of aromatic compounds are alkyl substituted benzenes, are named in two different ways. When carbon chain is less than 6 carbon chain, this is a carbon chain, remember, is less than 6 atom, the compound are named as alkyl. This is alkyl substituted benzene. This is what you call it, propyl group. Since this is a propyl group and this is benzene, so we will call it propyl benzene. But what will happen if the carbon chain is more than 6 atom? Let us see what is that. In this case, this is the carbon chain which is longer than 6 atom. If the carbon chain is 6 or more than 6 atom, then the benzene ring is considered as a substituent called phenyl, and the compound is named as phenyl substituted alkane. Remember, this is alkane. You will find only single bond, there is no double bond in between. So this is alkane, and benzene is attached to the carbon number 2. Remember, benzene is attached to carbon number 2. That's why we will call it 2. This here we will call it phenyl. Phenyl, and phenyl group is attached to carbon number 2. So we will call it 2-phenyl octane, because it has 8 carbon atom. Other category is the benzene containing carbon chain with functional group, irrespective of the chain length. It is also considered as a substituent. Here chain length don't play any role. Irrespective of the chain length, we consider is as a substituent. So in this case, this is a phenyl group and this is alcohol, you know it very well. The 2-phenyl ethanol, this is ethanol, you know it very well. This is ethanol, and phenyl group is attached to carbon 2. Carbon 1 is this, one carbon is that carbon which is very near to functional group. So carbon number 1, carbon number 2,